In mathematics, more specifically complex analysis, the residue is a complex number proportional to the contour integral of a meromorphic function along a path enclosing one of its singularities. Residues can be computed quite easily and, once known, allow the determination of general contour integrals via the residue theorem. Definition: the residue of a meromorphic function at an isolated singularity, often denoted or, is the unique value such that has an analytic antiderivative in a punctured disk. Alternatively, residues can be calculated by finding Laurent series expansions, and one can define the residue as the coefficient A1 of a Laurent series. The definition of a residue can be generalized to arbitrary Riemann surfaces. Suppose as a one-form on a Riemann surface. Let be meromorphic at some point, so that we may write in local coordinates as. Then the residue of it is defined to be the residue of at the point corresponding to. Example: as an example, consider the contour integral, where C is some simple closed curve about 0. Let us evaluate this integral using a standard convergence result about integration by series. We can substitute the Taylor series for into the integrand. The integral then becomes. Let us bring the 1/z5 factor into the series. The contour integral of the series then writes. Since the series converges uniformly on the support of the integration path, we are allowed to exchange integration and summation. The series of the path integrals then collapses to a much simpler form, recall that. So now the integral around C of every other term not in the form xr1 is 0, and the integral is reduced to the value 1/4 is the residue of a z5 at z equals 0, and is denoted. Calculating residues, suppose a punctured disk D equals z, 0,